Welcome to this online course on hydrogen technology, cryogenic hydrogen technology to be very precise. And by this time all of us are familiar with the terms hydrogen technology, hydrogen economy, hydrogen energy, but there is an additional term cryogenic, but this cryogenic is not an adjective to hydrogen, rather it should be read as hydrogen energy and what is the role of cryogenics in it. So, let us look into it, and this is an introduction course today. So, we will give you a brief introduction with the course outline and we will try to understand what it means. So, these are the keywords hydrogen energy vector and cryogenics. So, let us start with the brief milestones of hydrogen, and we will find that some of the major milestones starts with the invention of hydrogen. When it was first generated, it is known that Robert Boyle generated hydrogen for the first time by dissolving iron into in sulfuric acid. Later on, Henry Cavendish specifically precisely measured its density and specific weight, and subsequently Lavoisier named it as hydrogenium, because this hydrogenium is named because it is a mixture of hydrogen and oxygen gives or produces water, and from there this hydrogenium this symbol H finally arrived. So, it was James Dewar in 1898 first time liquefied this hydrogen, and it was at that time, during that time it was known that some of the so called these gases are so called permanent gases like nitrogen, oxygen, helium and say hydrogen. All these gases cannot be liquefied just by applying pressure, and later on it was found that the concept is not correct and they were able to liquefy hydrogen. James Dewar is the person who liquefied, and not only that, he liquefied it in a good quantity and he could preserve it in a container, basically a double walled container, and still that container is in use. That concept of that container is still in use for storing the cryogen, and it is named as small Dewar, and it was in 1898. Subsequently, in 1926 we found that the Fischer-Tropsch process came for production of liquid hydrocarbon, and we have seen that this hydrogen fueled rocket was fired by USA in the year 1963. So, that means it has a long, these are some of the milestones, it has a long history, and we are now in the 21st century trying to figure out this hydrogen economy or hydrogen technology for our future application. So, let us try to look what is new in it. So, the present scenario is that hydrogen is used in many chemical and oil refineries, and they are being used as reducing or hydrogenating agent. For example, that if we have to use reduce or hydrogenate the fatty acids, sometime it is edible or inedible, and depending on that this will be producing either soap or mayonnaise, or in oil refineries both it is produced and as well as consumed, and for space application we know that hydrogen is used as fuel. So, this hydrogenating agent means in case of say ammonia production, for example, this is a mixture of nitrogen and hydrogen, and this again say for example, in oil refineries, if we have to remove say the sulfur, we need to hydrogenate it, and as synthesis gas, this is a combination of CO and H2 that is again used in plenty in several chemical industries and oil refineries. So, these are already known to us, and in the future what we want to do is that we want to use hydrogen as fuel, though it has limited applications in space. We want to use it as fuel for running our car, running our buses, train, etc. I mean, for everywhere where the diesel or the petrol is in use, we want to replace those with hydrogen. So, not only that, we want also this generation of hydrogen from the non-fossil fuel. So, that means when we are talking about generation of hydrogen from non-fossil fuel, that means hydrogen, is it not available freely in air or in atmosphere? The answer is no. We do not have hydrogen available in air, but rather it is available as ppm level. So, if we go something like 100 kilometer above the earth's surface, this is linear, and that linear is mostly contains hydrogen, but nobody is going to pick up this hydrogen from 100 kilometer above the atmosphere. So, what is the source of hydrogen then? We have a stable compound on atmosphere or on earth, that is water, but as I have said that it is a stable compound. If we have to get hydrogen from water, we need to break it up. And so, what are the other sources of hydrogen other than this water? We have talked about the application of hydrogen in chemical industries, say, or in oil refineries. So, what is the source of hydrogen in all these chemical plants or industries? So, these are basically the coal, crude oil, natural gas. These are basically the fossil fuels. You can understand that this civil industrialization started with coal, subsequently crude oil was discovered and natural gas came in picture. So, these are the sources of hydrocarbon. So, sources of hydrogen, these hydrocarbons are the sources of hydrogen. So, as you can understand that these are some stable compound, and if we have to free hydrogen from these stable compounds, we need to have energy. So, that means hydrogen is not a free source of energy, but we have to free this hydrogen from some compound. That means we have to use some energy to get this hydrogen or hydrogen energy from hydrogen. So, that means it is the energy vector. Just like electricity, this electricity will not be available freely, you have to spend energy to create this electricity. Similarly, this hydrogen energy, if you have to get, you have to first spend some energy to generate it from water or coal or crude oil or natural gas. But what are the let us look into the C by H ratio, that is carbon to H ratio for all these materials or the hydrocarbons. Say coal is having nearly about 2 carbons per hydrogen, crude oil is having nearly 0.5 and natural gas is having 0.25, and with the hydrogen there is no carbon. So, what does it means? Because when we are trying to convert all these hydrocarbons into or trying to generate hydrogen out of these hydrocarbons, there would be cogeneration of CO2. That means, the amount of carbon present in these compounds will also matter. So, if there are more carbon present in these compounds, obviously there would be higher CO2 cogeneration. Okay. So, these are the first 3 of these compounds are basically fossil fuel, and from there if we try to generate the hydrogen, we will find that there is cogeneration of CO2 except for hydrogen, since it is not having any carbon in it. So, there would be any cogeneration of CO2, but why CO2 is not good? CO2 is not good for the environment, as we all know that it is causing global warming. Okay. So, we have to reduce the carbon emission or CO2 emission into the atmosphere, and that is why we find that this hydrogen is the best fuel among all these elements. Okay. But we are still bound to use this fossil fuel, and that is also depleting with time, and we have to reduce our dependency on these fossil fuels in future for the generation of the hydrogen. So, we will look for an alternative source of this hydrogen other than this fossil fuel. So, we have understood this hydrogen is the future fuel. So, let us look into it. We have said that it is cryogenic hydrogen technology. So, we have understood about the hydrogen and hydrogen technology. Now, why cryogenics is coming in picture? So, before that we need to understand what is cryogenics. So, cryogenics is a science and technology dealing with the production, maintenance and utilization of low temperature below 123 Kelvin. In terms of degree centigrade, it is minus 150 degree centigrade, but usually in cryogenics we always talk in terms of Kelvin. So, we have to now look into this cryogenics and let us just briefly look into the cryogenics and what is its role in the modern society. So, in steel making, I mean in large or tonnage steel making, you will find there is enormous application of cryogenics. Whenever this steel is made, you will find that it needs oxygen. That oxygen comes from the air separation, where you need large cryogenics application or large cryogenic engineering applications. Then in medical science, if someone has fallen sick and he has to do the MRI, that MRI needs a very large magnet or strong magnet, which is often generated using the superconducting magnet or superconducting wire. That superconducting wire has to be cooled with liquid helium often, and there also you have the application of cryogenics. Then for biological sample preservation, be it what is called the stem cell preservation or any biological samples, often you will find that they are cooled to 77 Kelvin for storing the biological samples. And also the blood preservation and body tissue preservation are done at low temperature, mostly in cryogenic condition. Then there is application in the strategic, another two strategic sectors, one is space and there is defense. So, in space we have learned about the Hubble telescope, then we have the James Webb Space Telescope. Our knowledge about this universe is mostly dependent on this cryogenic applications for space. And also say in defense, you will find that when the missiles are fired, it has an IR sensors, which is to be again cooled using liquid nitrogen or some small cryocoolers. So, in everywhere by and large in modern society, you will find applications of cryogenics, and particularly with respect to this hydrogen, you will find that it is basically this liquid in the form of liquid hydrogen is basically a cryogenic fluid. So, let us now move to the when we are when we have decided this, that the hydrogen is the future fuel. So, what is that infrastructure that will be necessary to use this hydrogen as a future generation fuel? So, we have learned that hydrogen is not freely available in atmosphere. We have to generate it from the hydrocarbons at present. So, in future maybe we have to generate it using the non fossil fuel, using renewable energy preferably. So, first of all we need to generate hydrogen. So, either it is at this moment we are generating it using fossil fuel and there is cogeneration of CO2. If we have to basically develop hydrogen infrastructure, that has to be, and it has to be free from CO2, then we need to look for the non fossil fuel as well as the renewable energy. So, hydrogen generation, it will be I mean, along with that we have to look for its storage as well as distribution. So, you can understand that this hydrogen is basically it comes on the, it is the first element in the time periodic table. So, in the periodic table, that if it is the first element, that means it is very lightweight. So, obviously, if we want to store it in the gaseous form, it will occupy a very large volume. So, often it may not be practical to store it in the gaseous form. So, either we have to compress it or we have to liquefy it, and then finally, this stored or stored liquid has to be distributed to different I mean wherever we want to use this liquid or gaseous hydrogen. So, there are different hydrogen generation processes at this moment. There is coal gasification, then partial oxidation of the crude oil, then steam reforming, which use mostly the methane and or the natural gas, and then you have water electrolysis. So, this first three coal gasification, partial oxidation and the steam reforming, all these processes are based on the what is called the fossil fuel. The water electrolysis is of course not depending on the fossil fuel, but it is still an energy intensive process. We have to look into it in details when we talk about this hydrogen generation in the future. So, there is also this hydrogen generation we have to look into, that is using, as I have said, that using the renewable energy resources. Then comes the storage and distribution. So, as we have learned that this hydrogen is the lightest element, and obviously, we have to compress it to densify or to increase its density, and then you can of course transfer it by the pipeline. But other option is to liquefy it, and when we liquefy this hydrogen, its boiling point would be in the cryogenic domain. So, if it is in the the gaseous form and if it is compressed, it will densify it to certain extent, and then we can transfer it through the pipeline from one end to the other end of the country. Then it can also be transferred by bundle trailer. That means, we have high pressure cylinders, like we transfer the oxygen from one end to the other end of the country or the cities. So, similarly, where the hydrogen is getting generated, it can be compressed and put in a cylinder like that, and it can be put on a trailer to bring it to the point of use. The other option is storing the liquid in a in a container, and like you have seen on the highway, that when you are passing by, you will find that there is liquid nitrogen container in a truck, or the liquid oxygen is being transported. Similarly, from the point of generation of say this hydrogen, where it will be liquefied, it will be transferred to the point of use. Like if someone wants the liquid hydrogen driven car to be filled, he has to go to a filling station where liquid hydrogen will be available, and that filling station has to be supplied with this liquid hydrogen coming from a different station, or it will come it will be on board, or it will be generated in that filling station itself. So, subsequently it comes its utilization part, so be it a car, personal car, or bus, or train, or the aeroplane. So, probably this liquid hydrogen would be the only option for some of the applications, though some of the buses and cars are these days running in Europe with the compressed gaseous hydrogen, but for aeroplane application, or this aeroplanes, probably the liquid hydrogen is the only option. So, apart from that, we have on-site production and storage of hydrogen, that is also possible, but if it is in a large scale application, probably we have to look for the cryogenic storage and transportation of this hydrogen. So, now let us look briefly into the course content. As we have already discussed, that we have to look into the different hydrogen production techniques, both existing and the futuristic, because the successful implementation of this hydrogen energy will be dependent on the production, and as we have learned that it is an energy vector, we need to spend energy to generate the hydrogen. So, we have to have energy efficient process for generation of hydrogen. So, for generating hydrogen, it should not be that we spend energy more than what it is can give. So, that we will look into. So, what are the available or what are the existing hydrogen production processes from the fossil fuel, and what is the role of cryogenics in that hydrogen production. And then of course, there are different hydrogen storage means. Mostly we will look into the compressed as well as the liquefaction or liquefied hydrogen. And when it is liquefied hydrogen, as we have learned that it is in the cryogenic domain. So, its storage, its liquefaction process, it is it is completely different from the other refrigeration processes. So, we will look into that cryogenic liquefaction process, and then there are other storage means like storing hydrogen in metal hydride, cryosorption storage, then cryocompressed hydrogen is also those are all futuristic methods, and we will try to look into it from its utilization point of view. So, for utilization we will look into mainly hydrogen as a fuel, where this hydrogen will be using at present it has limited application in the space technology or cryogenic rocket or cryogenic engines. And other than that, if we have to use this liquid or gaseous hydrogen for running a car, we have to either look into a suitable engine, or where the gaseous or liquid hydrogen will be directly injected, or we have to look into the fuel cell, where this hydrogen will be injected or supplied in the form of liquid, and finally, it has to be gasified and utilize it. So, other than that, we have the safety part. Whenever we talk about the liquid hydrogen. As such, liquid hydrogen, since it is in the cryogenic temperature, there is no problem, but as we try to store it in a closed container or in a confinement. So, it may because of the heat inleak, it may get pressurized and create safety hazards. So, we have to look into the safety aspects of using the hydrogen. Other than that, what it is important before we start this discussion on this cryogenic hydrogen, we have to look into the hydrogen properties. There are very peculiar properties of hydrogen, both in particularly in low temperature. So, we will be looking into it in details in the coming lectures. So, let us look into the references. So, mostly we will be talking about the cryogenics part of hydrogen from Cryogenic Systems by R. A. Barron. Then there is one more book by Thomas Flynn. There are plenty of cryogenic books these days available, and this is about the safety part. So, these are some of the references what it came to my mind at this moment. So, later on I will also tell about the other references. So, let us try to conclude. So, in conclusion we can say that we have learned that hydrogen is a prospective fuel, and hydrogen is the energy vector, and hydrogen infrastructure is necessary to create it as a future fuel, and there is a role of cryogenics, has an important role in this hydrogen technology. Okay. So, thank you for your attention. Thank you once again.